Hello, I'm Professor Sarah Bridle from the University of York. I'm Professor of Food, Climate and Society there. And this evening, I'm really delighted to be giving this Darwin College lecture on food and climate change. I really hope you enjoy it. Thank you.
Good afternoon, ladies and gentlemen, and welcome to the 2022 Darwin College lecture series. I can't tell you how wonderful it is to be back having a live audience here in Lady Mitchell Hall in Cambridge. So a very, very warm welcome to all of you who have journeyed on this cold day to join us. But we're also, for the first time, live streaming on the Darwin College YouTube channel. So can I extend a very warm welcome to the audience that particularly grew, I think, last year, where we had to be online only, all around the world, to these Darwin College lectures. We are, of course, as we all know, at a time in history when people everywhere are confronting a growing number of what we are increasingly calling global challenges. The coronavirus pandemic is probably uppermost in our minds at the moment, but we're also constantly reminded of the threats from climate change, biodiversity loss, increasing regional, global, national, even local insecurity, as well as the rapid changes in society and in science that are forcing us to re-examine the ways in which we live our lives and which we think about our lives at a personal level, at a community level, at a government and national level, and at an international level. And it's in that context that the issue of food and its role in our lives is, I think, really topical, interesting, important, and multidisciplinary. So for that reason, among many others, over the next 8 weeks, this series of lectures will examine the theme of food from a series of interdisciplinary perspectives. We'll be looking at ethical choices over food consumption. We'll be looking at how archaeology what archaeology, in a sense, can tell us about the role of food in the distant past, and how science is increasingly helping us to refine the choices that we make about what we eat now. We'll be looking at the production of food and its wider impact on our physical and social landscape, as well as the role that food plays in our lives, both aesthetically, historically, politically, and nutritionally. And what better way to begin that topic by starting with food and climate change. And therefore it is an enormous pleasure to introduce our first guest speaker, Professor Sarah Bridle, to talk on that subject. Sarah, I've discovered, of course, in preparing for this, has had a fascinating career. She very wisely started reading natural sciences here at Cambridge. She then did a PhD on Bayesian methods in cosmology and postdoctoral research at the Astrophysical Laboratory in Toulouse, whilst doing a research fellowship at Selwyn College here in Cambridge. She subsequently held academic posts at University College London and the University of Manchester. She's a prolific author, speaker, writer, communicator, and her work has been recognised, and she's by receiving a number of awards, from an early career Royal Society Research Fellowship, the Royal Astronomical Society's Fowler Award, the L'Oréal UK and Ireland Fellowship for Women in Science, and was nominated as one of the top 10 UK scientists under 40 by the Times Eureka magazine. As I say, she began as an astrophysicist, but in 2015, inspired in part by her mentor, the extraordinary, pioneering late Professor Sir David Mackay, a former fellow of Darwin, Regis Professor of Engineering at Cambridge University, Chief Scientific Advisor to the UK government's then Department for Energy and Climate Change, and of course author of Sustainable Energy Without Hot Air. It was Sir David, I think, who inspired Sarah to adopt a new research direction, embracing agriculture, food and sustainability, and making use of those analytical skills that she had gained as an astrophysicist. So following her transition from dark matter to food, Sarah has recently been appointed as the Professor of Food, Climate and Society at the University of York, where she focuses on synthesizing, exploring, and effectively communicating the environmental and nutritional impacts of different diets so that she can inform and help shape policy and practice in agriculture and food production. Following in David Mackay's footsteps, she has written another wonderful book, Food and Climate Change Without the Hot Air, and that highlights how different foods contribute to climate change so that informs our decision-making about what we choose to eat and how we choose to live. And I can therefore think of no one better to speak on the topic of food and climate change. So please join me in welcoming Sarah Bridle to the stage.
Thank you. Well, thank you very much for your kind introduction and for some of the really relevant background to this talk. And thank you very much for coming and for watching online. So I'm going to reminisce a little bit first. When I was studying physics and other subjects at school and trying to decide what to do for my career, and there was a very pivotal day when we visited a friend of my dad's in Cambridge, and he took us punting on the river, and we sat in the rooms just upstairs in Darwin College, in David Mackay's rooms, looking over the river and thinking about how the tides are formed by the moon. And I just thought, this is what I want to do, and I just imagined that everyone in academia was just like David Mackay, which took me a while to learn that that's unfortunately not entirely the case, but a really inspiring time. And that led to about 20 years of astrophysics, culminating in a project where we got the largest ever dark matter map of the universe, which you can see here. And this project is still going on. But when we finished that first round, that first cosmology results from this project, I started to think about what to do next. My kids started at school, and around about the same time, I was at a meeting in Cambridge, and I bumped into David Mackay as I was... Which clicker am I using here? What's happened? That's worrying. There we go, okay. Bumped into David Mackay, typically on his bike, cycling between the Cavendish physics department and the centre of Cambridge. And it was then that I learned that he had terminal cancer. And that was a really, another pivotal moment in my life when I realised that this mentor who'd been so influential in my life was no longer going to be able to do the wonderful work that he'd been doing on helping with climate change and raise awareness of how different energy sources needed to change going forward. And this really was what indeed inspired me to change and really start to learn about climate change and think more about this planet that we're living on and the future for my kids as well. So I don't need to tell you, I'm sure, about climate change. And this graph, actually made by another former astrophysicist, shows you the average temperature every year since 1850. And most people would not argue that one side is redder than the other. And I don't need to tell you about the impacts of climate change. But these are illustrative pictures of the kinds of impacts of extreme weather, as well as the impact on ice sheets. All but one of these pictures is from the UK. You can probably guess which one. And so you can see the impact on flooding, droughts, and also the extreme winds that we can have with extreme weather events and climate change. And that will impact on food. So if we think about droughts and flooding, for example, then we know that that's going to have a significant effect on the food that we can grow. And what's very interesting about the way that's happening is that actually the food is more affected in more joined up regions than it used to be. So these extreme weather events are tending to affect larger areas of the planet in one go. And so this is particularly worrying if we need to, provide food and we can't rely on just importing it from somewhere else with extreme weather in just one small part of the world at one time. So this is extremely concerning from a food point of view, but it was also looking at what David had been talking about in terms of climate change. I looked through his, this is the penultimate talk he gave, a slide identifying food as being the biggest lever that we can actually apply to this system. It really got me interested in this topic. And so what I found was that actually it turns out that food contributes now about 1/3 of all climate impacts. A lot of people quite surprised that it's such a large fraction. And that covers all these different things from clearing land for agriculture to raising livestock, producing crops for livestock to eat, producing crops for us to eat, fertilizer, manure, processing, packaging, transportation, waste, cooking, and so on. So this is covering all of those different things, and we need to add up all of those different impacts to figure out the climate impact of something that we might buy and eat. And if you want to see more detail on that, then you can see this beautiful graph that I just showed here, which shows food on the left causing about 1/4 when this was made, and that's increased since then, of all climate impacts. And you can see how that compares with other things, for example, heating here and transportation. So once grouped together in this way, food is actually a very major cause of climate change. And the other thing that you can see in detail on this graph is that actually the majority of non-food emissions are to do with fossil fuels, but the majority of food greenhouse gas emissions are related to non-fossil fuel things. So that's very important because clearly we need to stop burning fossil fuels and we need to have renewable or clean energy. But once we've done that, food will still be there contributing to climate change. And what the science shows is that we need to also look at food, the food system. And it's really interesting because when we want to get to net zero greenhouse gas emissions, as recommended in so many reports now, then we also need to think about the food system as capturing carbon. But if we look at the food system alone, if we only had this red part of the graph and we managed to stop burning fossil fuels, the food system alone is projected to cause 2 degrees of temperature rise by the end of the century. So even if we stop burning fossil fuels, we will still have to change the food system. And the food system alone is the place where we can actually capture carbon. So this diagram here shows carbon dioxide being absorbed by crops, being released again, for example, if we burn those crops or if we eat those crops. We have emissions from fertilizers, nitrous oxide, methane, for example, from manure and ruminants like cows and sheep. But we also have CO2 being sequestered. We have carbon dioxide being pulled into the soil, pulled into long-lived plants like trees, and right down in the soil. And this actually is unique for the food system. If we look at all those other parts of the contributions to climate change, they're all contributing to climate change, but the food system can also help to reduce the amount of climate impacts. And so how can we get to the place where we're reducing the impact of climate change from food? Well, for example, the National Farmers Union has set out different ways we can do that. So we can be more efficient in the way that we produce food. We can also change the way that we manage the land. So this involves, for example, reducing the amount that we're ploughing up the land and disturbing the soil structure, which then releases carbon dioxide rather than sequestering carbon dioxide in the soil. And we can also have more renewable energy coming from farms and other outputs from farming. But also, there's this elephant in the room, as it were, which is that we also need to look at what food we are producing globally and in the UK, and thinking, is this actually the best balance of all the different types of food that we're producing, as well as all these other things? But at the same time, if we're taking, for example, a UK perspective or a single country perspective, we also need to make sure that if we're going to change what we're producing, we also need to change what we're eating. It's no good if we keep eating the same things, but then import more things from other countries, which might actually produce more greenhouse gas emissions if they're produced overseas. So this is a very complicated problem, which really needs systems thinking in order to reach a solution. And there's been a number of reports. This is one example from the Committee on Climate Change, recommending reduction in meat and dairy by 20 to 35% over the next 30 years. So if we think about how do we get a systemic change, how do we get the whole system, the consumers, producers, to change? Well, ultimately, we need better understanding. And that's, again, where I was inspired by David Mackay and his book, Sustainable Energy Without the Hot Air, as was already mentioned. And in that book, David took a very personalized approach. So this was, in his case, about looking at the energy used per person per day from all different activities. And it was also about how we can produce more energy from renewables per person per day, looking at the amount of land area, for example, available for different practices. And so that's really very much the same approach that I took in the food and climate change without the hot air. And so this is one example here. If we compare driving a car somewhere 12 miles away and back, then that causes about 6,000 grams, 6 kilograms of carbon dioxide effectively going up into the atmosphere. That's quite a hard thing to picture. I could lift 6 kilograms if I had to, but I could also, if we filled party balloons with carbon dioxide, that would correspond to about 200 party balloons going up into the atmosphere each day due to producing the food that we're eating. We could compare it with other things, which is more useful perhaps. So we could compare that with taking one return transatlantic flight per year, sharing out those greenhouse gas emissions across all the days of the year gives us a similar number. On the other hand, if we looked at food, if we look at the average greenhouse gas emissions caused by producing food per person per day globally, it comes out at about 6 kilograms. So all these are roughly comparable. And it also shows there's no point getting obsessed by exactly what you eat if you're also taking multiple transatlantic flights per year or driving significantly further than 12 miles a day. We need to get these things in balance and keep things in perspective and compare like-for-like numbers. So that's really very much inspired by David Mackay. So if we were to think ahead about what sort of target we might go for, then if we need to halve our greenhouse gas emissions in the next 10 years, as set out in the various international agreements, we're going to have a sort of benchmark figure here of about 3 kilograms, 3,000 grams of carbon dioxide per person per day. And I'm going to leave this bar on the next few slides so that we can now start comparing different food choices that we could make as individuals. And I'm conscious I'm going to do something a bit heretical here. I'm going to do some polls with you. I'm going to ask you to put your hand up for a few different options. And the main reason for doing that is to stimulate your questions. And again, I'm going to be heretical again and invite you to ask questions during this talk and see how we get on really trying to engage you. So my goal is that I want you to come out of this motivated to do something. I don't really mind what it is, so long as it's helping to reduce climate change. But I think that the more engaged we are, then the more likely we are to go and do something. So I really want to address your questions and concerns that specifically that you've got right now. So we're going to try this out. So first of all, which do you think causes more climate change? An 8-ounce steak and chips or a microwave potato and beans? And if you think that's too easy, I'm also curious how different you think they are. So first of all, which do you think causes more climate change? Hands up if you think it's the 8-ounce steak and chips meal option. Yes. More information. Great. Ask me what you want to know. How long have I cooked jack potato? Yep, 10 minutes. In the microwave. Excellent. Any other questions? That's exactly what I want to hear. Where's the beef from? Excellent. This is an average European number for beef. Great question. Any other questions? Yep. Great question. How would it compare if we were to use an oven instead of a microwave? I've got a slide on that, so that's a great question. Next question. How is the beef fed? Excellent question. So it turns out that there is a different, if we were to feed cows on grass, then about 6% of the calories eaten by the cow are burped out as methane. Whereas if the cow is fed on concentrated feeds like soy and grains, about 3% of the calories are burped out as methane. So there is a difference in the greenhouse gas emissions depending on what they're fed. However, if we're going to feed those cows on soy, then that also is driving deforestation, which also contributes to climate change. So those two things tend to balance out, but obviously it depends a lot on where that soy comes from, and other things like how the manure is treated, if it's stored or if it's spread as slurry. So there's a range of different values there, but it's not as big a difference as a lot of people expect. Great question. Any more questions? This is exactly what I want. Yep, at the back.
Are the chips and jacket potato from the same farm?
Say that again.
Are the chips and jacket potato from the same farm?
The chips and jacket potato from the same farm. Yeah, so I'll show you the chips are a relatively small part here, but the processing is more important than the potato production, so it probably doesn't matter too much. Great question. Okay, so that's brilliant. I need to remember to repeat the questions probably for the live stream. I'll try and do that as well. Fantastic. So, on average, for an average European piece of beef, an 8-ounce steak, then we've got about a factor of 20 difference between these two options. But it does depend on how the potatoes cooked, which we'll come back to. And we can compare both of these to this daily average target we might be going for. And what you can see immediately is that if you want to try to reduce your climate impact, then changing the quantity of beef would have a massive impact. You could basically halve the climate impact of your dinner by maybe choosing better quality but less of the beef if that's what you wanted to do. So there's big differences, and actually what the research shows is that people tend to maybe get things in the right order, but they tend to underestimate the size of the difference between different food options, and that's what this graph is showing. If people got the right answer, then they'd be straight along the diagonal there. Great. And in fact, it really depends a lot on the production system. And so what this graphic here shows is that if we look at beef, then there's a huge range. And so this range here means that actually at the top here, this is from beef that is driving deforestation. So for example, in South America, then that would be at very much the high end here. But we've got different peaks here. This peak here is for dairy beef. So if you're producing both dairy products and beef from the same cow, then you can share those greenhouse gas emissions out between those two products, and you can get a lower value here. So there's a big range. On the other hand, if we to look at some of the other options down here, for nuts, this is pretty cool. For nuts, if you actually start growing trees where you previously had crops, then the trees are actually sequestering more carbon every year than having crops which are cropped every year. So this is, you can actually have net negative here as well. So there's a huge range. On the other hand, there are some clear trends as well in this graph. So what do we do if we've got a huge range? Well, I'll come back to that later on. Okay, so I'm not going to do a poll here. Well, actually, I am going to do a poll because you did ask the question. So which do you think causes the most climate change? An oven-baked potato with lots of cheese and butter with beans cooking for one, or a microwave potato with beans? Okay, so who's going to go for the, which do you think causes the most climate change? Who's going to go for the potato with lots of butter and cheese cooked for one person in the oven? That's maybe, okay, great. And now who's going to go for the microwave potato and beans at this end here? There's a few options there. Okay, so there's a bit of a spread there. I'm going to show you the answer there. So what you can see is if you put the oven on, and if it's a fossil-fueled oven, and you put one potato in that oven and leave it on for 2 hours, then we'll produce the cooking times. So this is going to cause over 2,000 grams of greenhouse gas emissions, which is already a significant fraction of our daily budget. So that's all to do with how we're cooking this potato, whereas if we look at the microwave potato, we've got beans in a can. That's not a huge fraction of that. And we've got the microwave oven. I've put some relish on there, some sort of pickle perhaps as well. And we've got vegetable spread there instead of butter. So you can see that we can have a huge range again between these two different options depending on what we actually do on our plates and in our kitchens. Any questions about that? Great, over there. How does plant-based cheese compare with dairy cheese? So I think I need to preface any comment about the climate impact with something about the nutrition, which, as you may know, if you look at the ingredients on most plant-based cheeses, which are relatively cheap, then you'll find it's very purified fats, and there's not a lot of nutrition in there. So nutritionally, they're very different. But in terms of climate impacts, then so cheese typically causes about 10 kilograms of greenhouse gas emissions for every kilogram of cheese, whereas if you looked at a plant-based cheese, looking at typical ingredients, it might be more like 1, or less than 1. So it will really start to depend on the processing, whether it's been renewable energy used in the processing, as well as the ingredients and the packaging when you get down to the lower values. That's a great question. Thank you. Yeah, next question. Okay, so why does the potato, so we're looking at this bit here, 151 grams for producing a potato. What is that? Yeah, great. So that is largely to do with fertilizer. So when we put fertilizer on the ground, whether it's synthetic fertilizer or manure, then it's going to interact with microbes in the soil. And those microbes are converting the nitrogen in the fertilizer into nitrous oxide, which is a powerful greenhouse gas, about 300 times more powerful than carbon dioxide per unit weight. So there's that, and also if it's synthetic fertilizer that we've used, then it's also producing that and depends on the energy we use. Any other questions? Great, over there.
When you compare, find it hard to compare beans versus beef. If you compare, for example, calculate beef, would you then take into account from when a calf has been born in the whole process if that's through to the end?
Yeah.
Beans it was short, but now okay.
Yeah. Yes, exactly. So you've got to take into account that you've also got a mother cow who's got to live for a whole year to produce another calf. So all of that is factored in. Yeah, that's a good question. Great. One at the back.
Yeah, but we must actually dropped it how much of the carbon dioxide that comes from cooking. Maybe it makes sense in the rate of inflation. I'm just wondering, we've got a pile of emissions for the next 10 years. To what extent are we going to be able to achieve quite a bit of that if we manage to make the electrical grid source from renewable energy? Because if we carve that out as it is, I feel like our stakes are on that.
Yes, that's a great question. Yes, so the cooking will massively depend on how that energy is produced. And if we had an electric oven running on, from your solar panels on your roof, or if you were maybe displacing some of the heating that you were going to do by turning the heating down because you had your oven on, then we could get rid of that. So it really depends a lot on where your energy is coming from. In terms of the whole food system, then the latest calculations have shown that it's about a quarter of the food system greenhouse gas emissions are energy related. So we're still going to be left with the majority of those greenhouse gas emissions, even if we were to switch to renewable and clean energy. Great. Okay, I'm going to try another poll after this question. So that target is just based on saying if we're going to halve our greenhouse gas emissions in the next 10 years. So it's literally taking the number we're at now and just dividing it by 2. That's all it is. So it'd be great to do better than that, yeah. But it's just to give us something to compare with. Is it possible to get to zero with agriculture? I am going to address that, yes. That's a good question. Excellent, okay. And I won't talk about that right now. Okay, right, we're going to do another poll. We're going to look at these 3 options. So I'd like you to have a guess and really stimulate your questions. Oh, I've given you the answer. Oh, my goodness. Okay. Well, that was very, very honest of you, I'm noticing. What would you have guessed? No. Okay, right, we have the answer here already, which is that if we were to compare a bowl of cereal and a latte, coffee, and 2 boiled eggs, then we actually see that it really comes down to the amount of milk that we put into these. So if we were to have a latte from a coffee shop, it might contain a pint of milk, whereas we might put 200 grams of milk on our cereal, though my kids seem to put more, but anyway, that's a big difference depending on the amount of milk. And so really, that's the answer for the eggs there. Any questions about this one? Question here. Great, so what's the difference between a plant-based milk or a dairy milk? So, as I'm sure you imagine, it will depend on the type of plant-based milk, but on average, there's not a huge overlap between these 2 options. So plant-based milks tend to cause half or less greenhouse gas emissions compared to the dairy milk. And then it becomes, again, a question of what kind of fuel is used in the processing, and the transportation and the packaging are actually as important as whether it's almond milk or oat milk or whatever. So in terms of climate impacts, it really comes down to these other issues. Great question. Any other questions? Yep. How is the lifetime of the greenhouse gas in the atmosphere? Okay, yeah, great question. Okay, so yes, so I'm using values here which are about the amount of heat that's trapped in the Earth's system over a 100-year period for each of these different greenhouse gases. But actually, as you may know, methane has a much shorter lifetime in the atmosphere. And is actually much more potent for the first 10 years, about 80 times more potent per kilogram than carbon dioxide. But then it then breaks down in the atmosphere. So it's only about 30 times more potent when you average it over a 100-year period. So if we really wanted to calculate the total amount of warming, then we would need to look at the profile of that over a period of time. So the good news is that considering that methane has a short lifetime, we can actually make quite a big difference in the near future, whereas the carbon dioxide is going to be there for the next 100 years, roughly. It stays in the atmosphere for about that length of time. So we're kind of stuck over the next 100 years already with the carbon dioxide we've already put into the atmosphere. So that's one of the reasons why politically there's a big push on methane at the moment. But of course, if we don't simultaneously reduce the carbon dioxide, then we're going to keep accumulating that heat over the next 100 years. So yeah, what you can do is a more detailed calculation looking at the temperature as a function of time and trying to design that. I have some issues with that because, the international agreements tend to look at the surface temperature. So that when people say we're trying to limit to 1.5 degrees, they're talking about the average surface temperature. But actually, when we trap heat in the atmosphere, then we also have ocean recirculation, which has taken that heat right down. And so there's a debate about which metric to use there, and whether that's really the right one. So yeah, there's a complicated answer to that question. It's probably all I can fit in. Okay, great question. Next question. Yes. Yes, absolutely. So absolutely, we should look at the nutritional component. We get a lot of nutrition from that, drinking that latte for breakfast. I suppose the big question is, when people do that, do they then cut back on their lunch as a result? Maybe they do, in which case they've had a good dose of nutrition there. So yes, so I suppose I'm focusing today on climate impacts because that is the thing which is not so readily available. So people can look at the packet and they can feel how they feel. They can find out the nutritional information relatively easily. And I'm trying to say, let's include in that discussion something about the climate impacts. And that information is not so readily available. So let's include that in with all the other factors like convenience, taste, cost. All these different things need to be taken into consideration, absolutely. Yeah. Right, so where do we get this information from? Well, I think that's the big challenge, and I think that's what I would love to see, a real pressure to get that kind of information on the packets available to us, because there's a lot of people, a lot of food producers doing a lot of great stuff, actually, but at the moment, that information isn't passed on to us as a consumer, and we can't recognise that. So I think that would be, a massive step forward. Otherwise, we tend to be, maybe talking at cross purposes or with a lack of information about the detail on that. So I would love to see that information, and I would love, how do we get that to happen? That's the big question, I think. Great question. In front, yep. I have seen one recipe book, yes, but I'd love to see more. Excellent. Okay. Yep. That's a good question, yes. So the question is that a lot of this discussion can be about individual behaviour change, but actually is there enough going on pressuring the people who are producing the food to change their behaviours? Is that a summary? Yeah. So I think that, the research on obesity is actually very interesting because it shows that more information does not change behaviour, in brief. And so actually, that there's an argument that this is not helpful to provide more information. I actually think there's a lot of people trying really hard at the moment to change their behaviour in terms of food to be more environmentally friendly, but often with the wrong information or with misconceptions, for example, about plastic or foods that are brought by ship from other countries. They might think that was very bad for climate change, but it turns out it's not. So there's a lot of misinformation out there. So I think if we can help to redress some of that misinformation, that would be very helpful. And the other fascinating thing is that, we're clearly not going to be having an impact. I can't, whatever talks we all go around giving about this, we're not going to change the behaviour of the majority of people, for example. But actually, it only takes a small fraction of people to drive change in industry. So if we look at what's happened with plant-based options, vegan options, the majority of people are not vegans or even eating the vegan options, but the supermarkets are competing with each other to produce those options because they are being driven by a small minority of trying to grab people to move to their supermarkets. So we can have a disproportionate impact through our individual actions if we change. However, what I do see is very important is that when we have more information, we are then more receptive to policy changes. We couldn't have a sugar tax if we didn't have a wide awareness that sugar was contributing to obesity, which is a national health crisis issue. So I think that information is very important, but not in the way that most people necessarily think. That's a great question. Okay. Yep.
Is the fact that locally sourced food, is that brought into the calculation?
Yeah, great question. I'm going to do another question. In fact, I've learned my lesson. So just before I just move on to another slide addressing that point, just to illustrate that actually sometimes it's more about quantity again than it is about what you put in. When I first heard about the climate impacts of food, I might have been boiling a minimal amount of water in my kettle, measuring it out, having a black tea, feeling very sad because I wasn't having my usual tea. But actually, if we look at a typical cup of tea with a normal amount of milk, a tablespoon of milk in there, it's got a much lower impact than a latte with a whole pint of milk in it. So I think, again, about quantity is something to bear in mind. Okay, I'll come to the transport question after this. So I'm going to do another poll now. Which do you think causes more climate impacts, a chicken sandwich, a cheese sandwich, or a peanut butter and jam sandwich? So have a think about that. Okay, so I'm going to ask hands up if you think that the most climate impacts come from the chicken sandwich. Hopefully it's stimulating lots of questions you're now thinking you need to know the answer to. Okay, hands up. Who's going for the cheese sandwich? Okay, and who's going to go for the peanut butter and jam sandwich? Okay, so quite a spread. Probably the cheese has just about edged it, but only just, I would say. Okay. And hopefully that's also stimulated lots of questions in your mind there. Okay, so you can see there is, if a European average chicken sandwich, then you're about here. The cheese sandwich just about wins because it takes about 10 kilograms of milk to make 1 kilogram of cheese, so that really concentrates that down. And a lot of people are quite surprised that even though the peanuts are coming from a different country, being transported by boat, that's actually still included in this calculation, but is also quite small. I do need to confess, though, that I've assumed 50 grams of chicken, 50 grams of cheese. It's about 2 slices out of a packet. I tried, for the purposes of research, a peanut butter and jam sandwich with 50 grams of peanut butter in it, and I can assure you it's too much. So this is just using 20 grams of peanut butter. So if you're concerned about being really fair, we should actually multiply this up a little bit. But in terms of practical sandwiches, I think this is a good comparison. So any questions about that? Or have we already answered all of these relevant points already? Yes, Andrew? Does it matter where the cheese comes from? Yeah, so there's different ways of producing cheese, different production systems, depends actually quite a lot on how the manure is managed on the farm. So it's really dominated by the production of the milk. It's not really about whether it's, the aging process is important actually. So if you had a soft cheese, it would have, it'd be more watery. So per kilogram, it would cause less emissions. If you've dried it out, you've concentrated that again. But it's dominated by how much milk is required to produce that bit of cheese. So then when you've got a dairy cow, then if those dairy cows are kept indoors and the manure is stored and collected, that will actually tend to produce more methane than if those cows are outdoors, which would mean that the manure is spread immediately and then turns into carbon dioxide, because it's decomposing with access to lots of oxygen, whereas manure, which is kept very wet, if it's kept stored, as it can be, then that will actually produce a lot of methane because the carbon is decomposing without oxygen, and so you get methane. So yeah, it does depend a lot on the production system there as well. Yeah, great question. Thank you. Okay, great. One more here. Yep. Great question. So yeah, so in terms of the chicken, where are the emissions coming from, and does it matter whether it's battery farmed or free range? So there's a range of different values. When you're talking about chicken, then the main cause, the biggest contributor, is actually producing the food to feed the chicken. So it really depends on what those chickens are eating. So actually, a significant fraction of the feed emissions comes from soy, for an average soy diet, when that comes from, on average, from deforested regions. However, if those chickens are in your backyard mostly eating insects or waste, then that's going to massively reduce. On the other hand, if you're buying a bag of pellets, it doesn't matter whether they're in your backyard or whether they're in a farm. If the pellets are coming from producing food in these deforested regions, then it is going to contribute to climate change. Organic chicken, organic is another question people ask about chicken quite often. And then it comes down to, for example, organic feed might have to travel further, and the chickens would live longer. So the longer the chickens are living, then they tend to eat more. So there can be actually a tension in terms of animal welfare there as well. But it's not a huge difference. Great. One more here. Yep. Great, yes. So with the manure, then you could actually store that and have a biodigester. So yeah, that is a possibility that then you could use it as gas. I haven't seen how much that changes the answer. Then you would be dominated by the methane coming out, the burping of the cows. That would be the dominant cause, and that would still be a relatively, that's about half, I would say, of that is coming from the cow burps. People have suggested you might put masks on the cows to collect the methane, but I think there might be animal welfare issues with that as well. A question here. Great question. So yes, there are things you can put in the feed of the cows, for example, seaweed, which can inhibit the amount of methane that they produce. What I've seen, the calculations I've seen, is that would reduce the amount of methane by 20, maybe 30%. Maybe we could imagine 40% with the technology. And then, as you say, you've got this issue of can you actually do that for all cows? That's going to be a major operation to do that. So yeah, you can reduce it, but it's not going to go away, basically. Great. Yeah, one more, and then I'll take you to the next one. Yeah.
Are you using UK-based figure for your calculation, or are you using world averages?
Yeah.
Or does this generalize to the rest of the world?
Yeah. So what I'm showing here are European averages. There is a variation, and that will again tend to basically be linked to deforestation with the biggest difference. And there's a debate about how you should handle that, really. But yeah, these are European values here. Great. Okay, we're going to do. Oh yeah, that's comparing with a steak sandwich, 50 grams of steak. Okay. Right, this is the travel slide, really. This is the main interesting point on this slide, I would say. So which do you think causes the most climate change out of a 25-gram small chocolate bar, a packet of crisps, regular-sized, banana, or an apple? So I'm going to do a poll now. So which do you think causes the most? Hands up if you think the small chocolate bar is causing the most climate change. Okay, quite a few hands there. Hands up if you think it's the packet of crisps. Oh, still quite a few. Okay, hands up for the banana. Okay, great, and hands up for the apple. No takers for the apple, okay. Great. So the first thing you can see is that you can hardly see these graphs here because they're all pretty small, which I was quite happy about. Yeah, you can see that the chocolate slightly edges, is slightly out in front there. It actually takes more than 25 grams of milk to make a 25-gram bar of chocolate. Did you know that? So you put powdered milk into a bar of chocolate, which means that there's a factor of 9 concentration, blah, blah. Anyway, okay, so that's the milk chocolate. Quite a lot of people go for the banana. We talked a little bit about shipping already, which might have tipped you off, or you're very smart here, well informed. So you can see actually in detail, if you can see very well, you might be able to see a tiny purple bar here on the banana. That is the impact of shipping the banana. So you can hardly see it. It's actually slightly less than the climate impact of producing the banana, and it's very much less than the greenhouse gas emissions budget that we've got here. So that hopefully addresses your question about the shipping. Yes? Yeah. Nuts, yeah. So how important is it to look at other things like water usage? Yes, so we do need to look at all of these things ultimately. And so, yeah, there are issues with producing almonds, for example, if that water is coming from underground aquifers or if it's coming from, very drought-prone regions and affecting other areas. So we do need to consider those things as well. I'm not covering that here just because it would be another talk and another book, which I haven't written. But, yeah, that's a very good question. Great, okay. And final poll. Which do you think causes the most climate change? A chicken tikka masala with rice, a lamb tikka masala, or a chickpea tikka masala? So I'm going to ask for a show of hands. Who's going to go for the chicken tikka masala? Hands up if you think the chicken tikka masala causes the most emissions. Hands up if you think it's the lamb tikka masala. Oh gosh, okay. Anyone left for the chickpea tikka masala? It's made using a tin of chickpeas. Yeah, we've got maybe one taker there. Okay, so this is the difference there. So the first thing you can see is that this is about 125 grams of chicken or 125 grams of lamb here. So you can see that the lamb, this really pains me, this slide, because I do absolutely love lamb curry. But you can see that with a typical amount of lamb in there, then it is already using up and beyond our daily budget. Okay. Great. So you're all spot on there. And if you want to see more of these things, you can see it in here. But most important, it's actually free online, thanks to funding from the University of Manchester and the fabulous UIT Cambridge publishers. Okay, so what do we do about this? We've got all these different values here. How do we deal with this? Well, I would absolutely love to see these labels, coming back to your question earlier. And, this is a point that was made by a leader in this field, Joseph Poor, who's working with others in the other place to work out how we might even represent some of these things, including water usage on packets, and that's lots of work going on there. This actually was done before. So in 2007, if you'd look closely at your crisp packet, you might have seen 75 grams of carbon dioxide was the amount that was produced by producing that packet of crisps. So that information was there. I have to confess, if I'd seen that in 2007, I would not have known whether that was a big number or a small number, and I'm not sure I would have had a clue what to do with it. And maybe not surprisingly, as a result, they stopped doing that. And so really this is a bit chicken and egg, as it were, that we need consumers to be wanting this information for it to be a market edge, to get producers to do it, to show that it's feasible, to get producers okay with governments bringing in policies, governments saying that these policies are actually feasible. So there's a sort of more going on here. There are some companies that are putting this information on their packets. There's a number of companies which are doing this kind of footprinting for food producers, and a number of movements to try to make this actually, bringing food producers together to try to do more, and nice apps like this which will help you to calculate the climate impacts of what you do at home. Yes?
So do you think getting that information across, so nutritional information, for example, slightly tracking, like green, amber, red, something like that would help people make a choice rather than say 75 grams of your 3,000?
Right, so rather than presenting it as just a number, to have a traffic light or something that puts it into context, would that make a big difference? Yeah. So what there's many different ways of doing it. It's it does have a slight difference. What actually the recent trial, I'm just trying to think if this is published yet, I think it is. Some of the trials have shown that actually in catering, for example, when people have done this in catering, the caterers themselves actually just are shocked by the differences between the different options, and so actually they change what's offered even more than the people themselves change what they're eating. So there's a few different aspects to this. Great, okay. And in fact, Denmark has said that these climate labels would be done on food. I'm going to just quickly come to one of the questions that you asked earlier about whether the food system could actually be climate neutral or even go beyond. We can talk about that too. So we had this daily benchmark of this 3,000 grams, this 3 kilograms. But actually, the food system is using up quite a lot of land globally. And so what we can see is how could we use that land? Are there different options we could have for that land? And it turns out that about, for 1 calorie, if we compare 1 calorie of plant-based product with 1 calorie of animal-based product, then there's a factor of 16 in terms of the amount of land that's needed to produce that food. Now, that varies in lots of details that we could talk about, but there's a big difference, both nutritionally and also in the amount of land that's used by different food options. If we were to again look at the UK, this diagram illustrates roughly what fraction of the land area in the UK is used for different practices. And so you can see here, for example, the amount of land that's used for cereal production, dairy pastures, beef and lamb pastures, and we've got the other uses, the non-food uses there, and pigs, for example. And we can also see here the amount of land that's used overseas for the food that we also import. And so you can see that also we're using up a fair amount of land overseas, including for beef and lamb and dairy. So if we were to change our diets to reduce the climate impact of our diets, then this could also free up land that we could use for other things. And in fact, that is an assumption built right into the major reports on climate change, that we're going to be freeing up land that we're going to use for bioenergy, carbon capture and storage, for example, and increasing the amount of carbon that's sequestered in the ground. And so we can compare different options. For example, if we were to cover 5% of the UK with solar panels, this is taken from sustainable energy without the hot air, we would produce something in the same ballpark as the energy that we use per person per day. Whereas if we were to restore a large fraction of UK peatland, we could sequester that budget that we talked about earlier per person per day. So if we were to look at the amount of carbon sequestered by restoring peatlands, share that out among each person in the UK, then it would turn out to sequester basically the same amount that we were producing by producing that food. Alternatively, if we were to cover 20% of UK agricultural land with fast-growing trees or 40% of agricultural land with broadleaf trees, we could also sequester that same amount. Or if we were to have carbon capture and storage, we were to grow perennial grasses in the UK on 25% of UK agricultural land, we could sequester that same amount, or we could do different combinations, different amounts of these things. If we were to somehow do all of them, then we could sequester a lot more than the amount that's produced by food, and actually that is key to net zero, because there are other sectors that are not going to be stopping as well. So this is really crucial. Any question? Yep. Yeah, that's a good question. So basically, given that the different gases live different amounts of time and we're only sequestering carbon dioxide here, but we're producing methane, then I suppose what we would be having is that we could help to get rid of some of the carbon dioxide that's already accumulated in the atmosphere from our activities in the past, as well as maybe balancing out the future ones. And then in terms of methane, then we would have this additional short-term effect. So yeah, on average over 100 years, which I think is the most, well, different people would say different things, basically. Yeah, it's a good question. Yeah. You need to do a whole calculation, look at T as a function of time, deep sea. So last question, and then I need to let you out of here. No.
If you use like 25% of the land instead to do bioenergy, carbon capture and storage, is the carbon capture and storage bit a gamble on an untested
Yes.
technology?
Yeah. So this is a big question. Carbon capture and storage. It's tested on a small scale, but can we do this on the scale that's required? There's a debate about that. I'm going to have to just wrap up because I know that I'm going to get thrown off at some point. So I'm going to just move on and just really just let you know about some resources which you can download and play with at home. There's a game that you can get people playing. If you kids like this one, then you have to check on which one you think is the lowest greenhouse gas emissions and then the next lowest. Have a go at that. Download these cards. There's 72 different flashcards you can download, print out, guillotine, or get printed, showing, you can do whatever games you like with these. That's quite fun. All the data for all this is online. We're working with different countries to make regional versions. There's a calculator on our website where you can make do your own calculations. For example, this latte there, you could change the amount of milk in that if you wanted to do that. And there's resources we developed together with colleagues, and you can see lots of useful tools there, and been brilliant working with. You can see the Lees score here. Been brilliant working with you on some of these things. Worksheets, you can do some calculations of the greenhouse gas emissions from a shower or boiling the kettle, from bananas that have been air freighted, sorry, strawberries that have been air freighted or bananas that have been trucked, and so on. So you can download all this stuff and play with it to your heart's content. And I really hope, we as a team really hope that you find some of this useful. And I'm really grateful for all your questions. It's been super fun doing this with you. And thank you so much for joining in. And thank you again.
Well, enormous thank you, Sarah. That was inspirational. You said David Mackay inspired you. He inspired many of us, but we are eternally grateful to him for inspiring you, and to you for following that career path. I thought this was a lovely example of how you've taken an interdisciplinary journey, if you like, from astrophysics to food production, consumption, a systems approach, and looking at both policy and practical action about what people can do. I also found it very inspiring and helpful to hear not only that food is part of the problem for climate change, we hear many of the problems, but your focus on solutions. That is the only way in which we are going to cope with those global challenges, is by finding new innovative solutions, and you've done that, but shown us how to do that through a analytical, research, well-informed approach, and I wish more would do the same. You asked us, or at least your plea, I think, was that we all go away and do something different as a consequence of your talk. So I hope you will all go and do that. I've been thinking about what I'll do, and sadly, I think it's probably drink less of the wonderful lattes that we get in the college cafe, or at least ask for less milk. I've already done quite a lot of the other things in terms of eating less meat and trying to buy locally and more plant-based stuff, and the college indeed has made that much easier than it is in many places. Next week, we are joined by the vet, Professor Andrew Knights, who will, I hope, answer his own question, which is, should cats and dogs go vegan? So please join us for that, online or in person, if you can. But now can I just ask all of you to join me in saying a very warm thank you to Sarah once again for such a wonderful talk. And now I think it's time to go and eat, but choose carefully. Thank you very much.
Thank you very much. Thank you. Thank you.